All right, patterns and nonlinear functions.
So today we are looking at just like linear functions that make a line, nonlinear functions don't make a straight line.
So nonlinear, not a line. There you go.
Mind blown. Anyways, but you can also represent them using words, graphs, tables, etc., etc.
Yep.
So that's what we're looking at. Let's talk about nonlinear function.
So write this down. Nonlinear function is a function that is whose graph?
Yeah, that is whose. Take out here.
Whose graph is not a line or part of a line. There you go.
There you go. All right. So here's a linear function. Line, line, line.
Yep.
Here's a nonlinear function.
Not a line.
A U, a squiggle, a V.
Not lines.
Those are not straight. Well, this has straight lines, but it's, again, you can't have two.
Correct.
All right. So classifying functions as nonlinear or linear.
Okay.
Okay. Talk about the pizza.
Okay. So the area A in square inches of pizza is a function of its radius R. So in inches. So the cost C in dollars. I hate these things. Of sauce for the pizza is a function of the weight in ounces of sauce used. Graph these functions shown by the table. Is each function linear or nonlinear? Okay, so there's a lot of information in that one sentence. Okay.
All right, so we have the area is directly changes based on the radius.
Right.
We have the cost of the pizza changes depending on how much sauce.
So we have two graphs given, two tables given, and two graphs to give.
One about pizza, one about sauce.
Right. So notice how these graphs, they're not very specific, right?
No, we're going to do a sketch, right?
Right. So we're just marking things about where they would be, and then we're going to figure out if it's linear or nonlinear based upon that.
Cool.
Okay. So you kind of create your own grid. You create everything based off of what you want.
All right.
Okay. So it's already labeled for us. So with the pizza area, we have radius as our x-axis and area as our y.
This looks like it's going up by 2s every single time. So it's an increase of the radius.
Okay.
And it's a constant rate.
Right.
Is this increasing at a constant rate? Do we need to grab a calculator for this? No.
No.
Well, not from here to here. What's 50 minus 12? 38?
Oh, yeah. But we can just start graphing this. So if you were to pick over 2 and up to 12, so you can just kind of mark it.
Oh,
you know
I see what you're saying.
Yeah.
I'm totally leading you down the wrong path. I was trying to make it so that I knew like how much increase in
Right.
Okay, so now let's just so radius over 2 up to 12. It's going right here.
So if that's about 10, so if we go over to 4 and then we go up to 50, that'd be quite a bit jump, right?
Mm-hmm.
And then over to 6-ish, so over a little bit more, up
100, about double that space.
Double that.
Oh man, I should have.
Start a little high.
I did start a little high.
And then we go over to 8-ish, right? So we're just ball pointing this. We're just ball parking this.
Ballparking the points.
There
so
you
then
go.
Up here.
Okay.
And then up here.
And then another 100 and then some. Okay.
So this is.
Okay. So it's kind of arcing a little bit. Is that what you see?
Yeah, I see this happening.
Okay. Now with our sauce cost.
Okay, I'll try to make it less hard.
Okay. So if we were to go over to 2 and up 80 cents. Okay. Over to 4 and up $1.60.
That's double the amount, so I'm going to go the same
double.
distance. Oops, I'll do smaller. Don't put it there. Put it closer. Put it right here.
Okay.
Okay.
Then if we go over to 6 and then up to 240, isn't 24 added? Yeah, I think this is a pattern here, right?
Mm-mm. It's plus 80 cents here.
Uh-huh.
And this is also, yeah, it is.
Yeah.
Is that plus 80 cents? Oh, I was thinking doubling. Yeah, so we're adding 80 cents every time. So then
it should just be in a direct line, correct?
Yeah. I mean, if you add the same amount of stuff, here we were adding, that's why I was doing all this stuff. We were adding way more every time. Here, I'm literally consistently going the same amount. So this could have a line that fits it.
Yep.
Okay.
So which one's linear?
The sauce is linear.
Sauce is linear. And nonlinear would be the arc.
Mm-hmm.
There you go.
Okay. Sorry I made that hard. Okay.
Okay, hang tight with this one. Representing patterns and nonlinear functions.
Okay.
So the table shows the number of blocks in each figure below as a function of the number of blocks on one edge.
Okay, so the total number of blocks is dependent on how many blocks are on one edge here.
Right.
Got it.
Okay. So the number of blocks on an edge, so we're looking at the table, okay? Fence decorators.
See about ours.
Okay. So if we have one block, we have one total block.
And one edge block.
Right.
Oh, okay, never mind. That's what we already said.
Yeah, no, you're fine. Now, the second one, if I have 2 blocks on an edge, so 1, 2, what we just underlined in blue, that means that there's actually 8 blocks inside.
In the whole cube.
So if I were to count them, 1, 2, 3, 4, 5, 6, 7, 8, I can see that.
Yeah.
Okay.
Yeah.
But I'm not going to do that if we have 50 blocks.
No, that would be a pain in the rear.
Right. And so there's our pattern. So.
And then they've made it into ordered pairs. Here's X and here's Y.
Right.
And if we were going to graph it, that's what we would put.
Yep.
So
it says, what is the pattern you can use to complete the table? So what's happening from 1 to 1, that's kind of hard to tell. There's no pattern that we can tell there.
Right.
So the next 2 ordered pairs help us out. We see that it goes from 2 to 8, and then 3 to 27. So I could say, okay, it's 2 times 4 to get to 8. But yet 3 times 4 would not be 27.
So it's not times 4.
No. So what's another pattern that you can think of?
Well,
would it be doubled? So 2 squared is 8. What's 3 squared? 3 times 3 is 9, so that's not it.
Nope, it's not squared either.
Okay.
Okay.
What about cubed?
Could be. Let's check.
So 2 times 2 is 4. Times 2 again is 8. Okay.
Okay.
3 times 3 is 9. Times 3 again is
27. So we're cubing this. And
and
again,
that's how you figure it out, guys.
that's what we had. We just had to pretty much guess and check.
Yep.
So the total number of blocks is the cube of the number.
Cube means
to the 3rd power.
Yep.
So like this.
side cubed.
Okay.
So what's the equation?
Well, then our equation is going to be side cubed equals s cubed or x cubed.
Yeah.
So I like s. I'll use s. Why is
Okay.
that not working? So s cubed equals y. In this case, s is side.
Right.
And then our graph is going to, I'll pull that up for you if I can. Here's our graph.
That's our face.
Oh, shoot.
Look up.
Okay. So again, you can see. Now, is this linear?
Well,
It's curving.
got a twist to it.
So it's not linear.
Yep.
Okay.
So you would circle nonlinear.
Right. Oh, I need to do that right here. Here we go. Nonlinear. Cool. All right. Hi. There may have been a little bit of a jump. We had to do some editing.
Yeah.
So we're looking at number 2.
So here's another example of nonlinear functions.
Okay. And this is a doozy.
Right. So here we have a tree branch. Okay. It says, what is a pattern you can use to complete the table? So this is all we're given is 3 examples of the branches and then a table. So I see that according to my table, that if I have my first figure, there are 3 new branches.
Right. So in this figure,
The
figure
red.
number 1 has 3 red branches.
Correct. And then in figure number 2, it says that there should be 9 branches.
So as I moved from figure 1 to figure 2, there was 3, and then each one of those 3 got 3.
Right.
You see that from the red here. And then when we go to figure 3, now we had 9.
I was like, I can't.
I don't have enough fingers. But okay, so then from here, in figure 2, each one of these 3 reds gets 3 more to then give me 27 in my 3rd picture.
Right.
So what's happening here?
So each one of these gets 3.
So if I'm doing something 3 times 3 times, that's cubing something.
Right.
Okay. So we start with 3.
So whenever we write a rule, we always say start with whatever your base is. So start with 3.
And then
cube
the number of branches. No, cube the figure number. No. Take the number of branches
and cube it.
No, that's not right.
Because you always start with the base of 3.
No, we're starting with.
Start with 3.
Okay.
And then you have your x value cubed, or your x value up there.
Cube it using x value? That doesn't make sense. We're just taking it to the value of x.
All right.
Oh, yeah. And raise to power using the x value.
There you go.
So you're not going to have the
cube.
same power every time. We're not cubing anything.
Right.
Okay.
Right.
So we start with 3 and you raise to that next power every single
I think
time.
we were saying that branch gets cubed.
Correct.
That's what we were saying.
But then the next time it gets 9 whatever.
Right.
I don't know.
Niner.
I don't know.
Yeah.
So we're going to start with y equals, and we have 3. raised to whatever power it is, which is the number of figure
Right.
in order.
Now this is a hard one, and we know it's a hard one.
Yeah, it's
okay?
way hard, way hard. So let's put it on here. We've got figures. And then on this side, we're going to have branches.
Okay.
I can't write sideways like what?
So if we start with figure 1,
Right
we
here.
go up to 3 branches, so not very high. Then if we go to figure 2, we double, triple that, right? Because 6 would be doubled, 9 would be tripled,
Mhm.
if you shall. Then you go over to 3 and then up to 27,
Which is-
so more than that distance that you just had. And then we go to 4. Okay, wait. So we need to figure out what 4 would be.
Mm-hmm.
So let's do 3.
To
And
the
then your
power
caret
of
button, 4 would be 81.
Well, that's going to be off the chart, way up here.
And
That's
then,
not even 4. That's like, it's going to be right here.
Okay. And then we would have 243.
For this?
Yeah.
Okay. Well,
These trees get a lot of branches.
yeah. And so that's like, look at this huge. I had to make it go way up here. It's boom. Oh, man, that's horrible. That's supposed to be a
So
curve.
it's curved.
Mhm,
Yeah.
This is curving.
So is that linear or nonlinear?
Nonlinear.
Nonlinear. It's
Now-
not a straight line
The other thing I can see is that this is not increasing by the
by a
same
certain
amount,
number.
by
Mhm.
a pattern or the same amount every time. It has no constant rate of change.
Right.
Okay? Woo! Okay. So here's ordered pairs, and they represent a function
Mhm.
where x is your x value, y is your output. X is your input, y is your output. So we're going to, what is the rule that represents this function? So let's pop, oh, it says the completed table here. Do I need to do anything
Well, let's
different?
just start them off here.
Okay.
So the ordered pairs would be 1, 2. So we're just filling this in.
Yeah, just totally
Then
writing
2
it.
to 4,
And 2 and 4
3 to 8,
and 3 and 8. And we're getting that from right up here.
4 to 16,
4 to 16
and 5 to 32.
and 532.
So what is a rule that represents this function? Again, this one's pretty challenging. I see on the x's. Oh, go for it.
Well, I was just going to say, you can solve a simpler problem by writing a rule based on the first 1 or 2 rows and see if it works for the other ones. That's kind of what we were doing on the
Yeah.
last one, too.
Mhm.
So we were ahead of the game here.
Yep.
Helpful hint. Okay, so,
My change in x is easy. I
Mhm.
go up by 1 each time.
mm-hmm,
Now my change in y, I can go a couple different ways with this.
mm-hmm,
I can say 2 times 2, I get to 4.
mm-hmm,
4 times 2 is 8.
mm-hmm.
8 times 2 is 16. 16 times 2 is 32.
Okay.
So you're adding 2 each time?
You're not adding 2, because this
Sorry.
is plus 2, but this is not plus 2.
Right.
It's
So that doesn't-
multiplying by 2.
yeah. I
So-
said add, didn't mean to.
No, you're fine. So it's times 2 each time.
Mm-hmm.
So the number of y is directly related to the previous value.
Right.
So let's look at what our rule will be. Should I undo the table first?
Sure.
Okay. Oh, let me move it up for you guys. Well, it won't let me. It really won't let me. There we go. All right. So what rule produces 2 given an x value of 1? 1 times 2 is 2.
Mm-hmm.
And then y equals x plus 1 and so on and so forth. So it doesn't work here, and that's what they were talking about here. Use one of those first few rows and see if it works.
Right.
It doesn't work. Well, here's what does work. Y equals 2 to the x.
So it's very similar to the previous one we just did.
Mhm. So if you see, and I believe these are called geometric patterns,
Okay.
not arithmetic patterns, but if you see this, this becomes your base, and you always raise it to the value of x. That's how you write that's a geometric pattern, right?
Yep. And we just got lucky that we said times 2 each time.
That's true.
Because normally it takes us quite a while to figure that out.
That's also correct.
Yeah.
So
here is your lesson check. Okay? Figure this out.
you can do it.
Yep.
And you know what? If you are stuck, do something, because we're going to go over it tomorrow in class and talk about all the questions you have.
You got it. Make sure that's filled out.
Okay, we'll see you on the flip side.
Later.